Today we will do something very simple. We will talk about AMGM inequality, but not in a standard manner. So there is a standard proof of this inequality, which you will find almost everywhere. But the one that we will talk about is easy, I think easier, and more intuitive in nature. So let's see what we can say about this. We will start with something called an axiom of arithmetic or axiom of numbers. So axiom of numbers. So these are the facts that we will assume without proving. So what is that fact that we will be assuming? Well, we will assume that positive times positive is positive. So this is quite simple, and I think none of us have any problem in accepting this simple statement about numbers, that if you multiply two positive numbers, you will end up with a positive number. And we will see how powerful this simple statement becomes when we apply it in a proper manner. So here is a theorem or a lemma. Lemma is a short theorem that can be used to prove a main theorem. So what is the lemma? The lemma is this, that if you have two numbers, say A and B, suppose both of them are positive, and it is also given that their product is 1. So these two facts are given. We want to show that A plus B is greater than or equal to 2. So this is the thing that we want to show. If you know AMGM inequality, this is very easy. But for a moment, I would request you to pretend that you do not know how to do this problem. Let's see how easily and intuitively we can talk about this result. How can we prove this? And we will use this axiom of numbers that we have stated here. So let's see how we can do this. So there are two cases really. So case 1, A is equal to 1. Well, if A is equal to 1, or rather I can say one of the numbers is equal to 1. So let's suppose, without loss of generality, that number is A. If A is equal to 1, automatically B will be equal to 1 because their product is given to be 1. So this implies B is equal to 1. So what is A plus B then? Well, easy enough, it's 2. So this step was like very easy. If one of the numbers is equal to 1, then the other one has to be 1 because their product is 1. Then their sum is equal to 2. Now let's do the case 2, which is the more complicated one. So case 2, none of the numbers equals 1. Okay, so if none of the numbers equals 1 and if their product is 1, what can you tell about the numbers? Okay, let's take it very slow so that we understand what's going on. We are assuming that product of two numbers is 1. This is given. And we are also assuming that none of the numbers is equal to 1. Okay, so in that case, can both of them be greater than 1? Is this possible? Well, certainly not, because if the both of the numbers are greater than 1, then their product will be greater than 1. So this is not possible. Okay, how about the other one? So can both of them be less than 1? Is this possible? Well, certainly not, because if you multiply two numbers less than 1, the product will also be less than 1. So this case is also not possible. So the only possible case is this, that exactly one number exceeds 1 and the other one is less than 1. So that's the only possible thing. Okay, so without loss of generality, we can assume that A is greater than 1 and B is less than 1. I mean, we will just name the number larger than 1 as A and the number smaller than 1 as B. Okay, so if A is greater than 1, surely A minus 1 is positive. And if B is less than 1, then surely 1 minus B is positive, right? So if you subtract B from 1, since B is less than 1, the difference will definitely be positive. Okay, so we have two positive quantities. Now we will use this this axiom that positive times positive is positive. So two quantities, A minus 1 and 1 minus B, are positive, so their product will also be positive. Now let's expand this. So A times 1 minus AB minus 1 plus B is greater than 0. But AB, we know product of A and B is equal to 1. That's given. So I replace with that. So A minus 1 plus B is greater than 0, or we have A plus B is greater than 2. So do you see how powerful this very simple axiom of numbers is? You do not have to use anything fancy, and with so little axiom and so little formula. In fact, we did not use any formula, so to say. With just pure reasoning, we can get to this beautiful result. Now you can extend this result. So this is an extended lemma, and you have to use mathematical induction for this. So the extended lemma is this, so the statement is this: suppose we have n numbers, a1 up to an. So we have n numbers, all of them are greater than 0, each of them are greater than 0, and it is also given that their product is equal to 1. So these two facts are given. You can show that a1 plus a2, their sum, is greater than or equal to n. So this is a very beautiful result. In some sense, the sum of the numbers depends on the number of numbers. It's kind of counterintuitive, isn't it? So anyway, we can prove this extended lemma. We can prove this extended lemma using the previous trick and this axiom, and also mathematical induction. So clue is this: to prove this. So this is to prove. To prove this, use induction. That's the first thing. The second thing is use the previous trick. That's number 2. And number 3 is use the axiom. So these are 3 clues. So why don't you try this? Try to prove this extended lemma. And in the next video, which will be posted in the link in the description, so you can bookmark that page or go there to find the next video. There we will be using these 3 things and actually proving this extended lemma. And then using this, we will prove the AM-GM inequality. All of these beautiful results are coming out from this super simple axiom of numbers. And that's the beauty of mathematics. You don't want to use a lot of formulas. You want to use very simple ideas and build beautiful results out of them. Okay, I'll see you in the next video. Link in the description will take you to more beautiful ideas. Keep on doing great problems and take care.